All right, let's start with labeling our system. So I'm going to label A, B, and C for the three equations. Next, we're going to decide which variable to eliminate twice. So we have three choices. You could choose X, Y, or Z. But in my opinion, variable Y would be easier to eliminate because of the coefficients. So if you look at the coefficients, one of the coefficients of Y is negative and the other two are positive. So for these kind of situation, Y will be an easy choice to eliminate. And I'm going to choose Y. Let's write it down. Eliminate variable Y, and you have to do it twice. Don't forget. Let's first use equation A and B. Equation A has coefficient positive 1 for Y, and then in equation B has coefficient negative 4. And as you can see, these two numbers are not opposite numbers right now. In order to make them opposite numbers, I need to make the first coefficient positive 4. So that means I need to multiply equation A by positive 4. Let's write down that operation. Multiply equation A by positive 4. Once we do that, we could add that to equation B, and that's how we eliminate variable Y. Equation A times 4, that gives us 4x plus 4y plus 4z equals 8. Make sure you multiply every single term in that equation by 4. Equation B, we're not changing anything. You just copy it. 6x minus 4y plus 5z equals 31. And now we are ready to add. When we add, as expected, y cancel out. We have 10x plus 9z equals 39. Let's name this equation D. And now we need to eliminate y one more time. And this time I'm going to use equation B and equation C. So every time you eliminate a variable, you're going to use a different combination of two equations from the original system. Let's check out the coefficients that we have. In equation B, it's negative 4. And in equation C, it's positive 2. Right now, they're not opposite numbers. In order to make them opposite numbers, we need to multiply the second coefficient by positive 2, and that will make them negative 4 and positive 4, which will allow us to eliminate y. So the operation that we're going to be doing will be multiplying equation C by 2, and then we add that to equation B. Let's write down equation C times 2. So equation C times 2, that will be 10x plus 4y plus 4z equals 26. And then equation B, we're not changing anything, so you just copy it. 6x minus 4y plus 5z equals 31. Let's add these two equations. As expected, variable y cancel out. We have 16x plus 9z equals 57. And we're going to name this equation E. And now we have a reduced system of equations in two variables, x and z, which we can solve by substitution or elimination method. I'm going to use the elimination method. And the operation I'm going to be doing will be eliminating z by multiplying one of these two equations by negative 1. The reason is being right now, both of the coefficients of z are positive 9, as you can see. So you just need to make one of the negative 9, and that's how you could cancel them out by adding them. Let's do equation D. I'm going to multiply equation D by negative 1. And that will give me negative 10x, negative 9z equals negative 39. Equation E, I'm going to keep it. I'm not changing that. So equation E is 16x plus 9z equals 57. Once we do the transformation, we could add these two. As expected, z cancel out. If we add it vertically, we will get 6x equals 18. Divide both sides by 6, x is 3. Let's name this equation F. Once you have one of the variables solved, then the rest are just easy. You just substitute back into either equation D or E to find out z, and then substitute x and z into either equation A, B, or C to find y. I'm going to do F I'm choosing equation D. If I do equation D, so you could start with equation D, which is 10x plus 9z equals 39, where that x will be replaced with 3. So let's calculate what that is. You have 30 plus 9z equals 39. Subtract 30 from both sides. 9z equals 9. So that means our z is 1. Let's label that as equation G. So we're almost there. We have one more variable to solve, which is y. And you're going to use either A, B, or C. So I think the best equation to use is definitely equation A, because equation A looks much easier. So I'm going to use f and g into equation A, where f and g are just the values of x and z. What is equation A again? It's x plus y plus z equals 2. So you have grouping symbol plus y plus grouping symbol equals 2. And then inside the grouping symbol, plug in the values of x and z. X is 3, z is 1. If you calculate, on the left-hand side, it's 4 plus y. On the right-hand side, it's 2. Subtract 4 from both sides, so y will be negative 2. And that is our solution. As you can see, we have x equals 3, y equals negative 2, and z equals 1. So let's put that in the coordinate form. X is 3, y is negative 2, and z is 1. And this is our final solution. And you could box this or you could highlight this.